Hi, I'm Tom and I talk about code. Welcome to another Rust programming live stream. Today, I'm working on my compiler. Last time we started adding pointers and it went pretty well. We added an operator to take the address of something, and that pretty much worked. Seemingly, since I finished streaming last time and merged some other work in from my laptop, I've broken it again. So we're going to look at some tests straight up to see if we can fix that. And then once we've got that working, we're going to do the other half of pointers, which is dereferencing, right? Taking an address and assigning something or writing something to that address. Like not even assignment necessarily, but taking your pointer to something, writing to the address specified by that pointer. And there's gonna be two parts. There's gonna be a right hand side and a left hand side, and I'm gonna explain why when I get to that. But there's a bit of complexity. There's a bit of complexity about how this star actually works. Thankfully, I think my parsers are up to the task. Okay, so we'll keep the intro short today. We'll keep the intro short and start just looking at some code and looking at some stuff that's going wrong. Let's jump into my pointer test. The idea of this test, we wrote it last time, and I swear it worked, right? I thought I left last stream on a good note. The idea was that we define two globals, test and foo. We take the address of foo, and we expect that to be 2, because we put our globals before code. We leave kind of like a chunk, a block of memory where they're going to live. So we would expect that test would go at address 0 and foo would go at address 2, because these are 16-bit ints. So we would expect the thing that gets returned out from the main function in the A register would be the value 2. Let's test this and see what happens. We find that the value that comes out is in fact 0, which is not correct. So what goes wrong here? And we can have a look at the code that's actually executing, right? All of my tests print everything that gets defined, which is cool. And actually, what's probably easier is we can see that test has an address of 2. That's good news. That's really good news. So we should see, Lidword C0, C, Lidword. So we would expect that the number 2 would appear somewhere in this code, right? If we take the address of foo, right? So if we look at our code gen, and we look at how we generate the address of a global, well, we load the address to the C register. How does load address to work? Well, all it does is loads the immediate into the register. So we should see somewhere in this executing... Oh, it worked that time. Okay, it's just deterministic. Cool. That's even better. That's very, very good. So sometimes we get 2 and sometimes we get 0. Test foo. Wait, hold on. What does my test say? Foo. Foo. We take the address of foo. Ah. So the order these get defined in is non-deterministic? Yeah, of course it is. Of course it is. Do you know why it's non-deterministic? And this is really obvious once you think about it. Well, once I think about it at least. How do we define these in the context? We define them in a hash map. What's the problem with a hash map? The problem with a hash map is iteration order is not specified. Okay, so that really shouldn't matter. Oh no, but it doesn't matter in that case. But before we get there, we put them into a map. We put them into a hash map. So actually, we could do 2 things here. Let's just make this a vec. Let's make this a vec instead. It's gonna be a vec of pairs, string, a name, and a type. So for each thing, if we find a global, we now just say push, and we push the tuple. Very, very similar, right? And now, instead of values, we say iter fold sweet. Okay, so for each, I think this will still actually work, funnily enough. That should be how that goes. Nice, almost. Vec string found hash map. Oh, found hash map. Yeah, because we need to change the constructor to a vec. Okay, nice. And now we don't even need to include hash map. It's gone. Now when we make t, this will be correct every single time. We've removed the determinism because hash maps iterate in a non-deterministic order. So you can get different results. If you can't rely on the iteration order of a hash map in any sensible programming language. I know in Go they deliberately kind of randomize the iteration order so that it is very different every time. You end up with like explicit non-determinism, right? Just to discourage people from using it incorrectly. I think that's how I understand it anyway. And I've definitely had that bite me in Rust. Okay, excellent. Let's commit this as a single thing because that is really, really good. Pile. What are we doing? Define globals in deterministic order. And let's add this test as well. Oops. Lang tests, ptr tests. Cool. Excellent. Okay, well that was easy. Let's leave a nice little check mark here. Done. This is my favorite thing. Okay, now we're gonna have to talk about deref. We're gonna have to talk about deref, my favorite thing, whoops, in the world. One day I'm gonna remember to make my pages transparent so it's easier to flip between them when I don't have to fill, but today is not that day. Okay, so if we have, like if you're writing C code, right, you can say, if you have a pointer x, okay, so some variable x, you can say x equals 5. This is valid. This is allowed. Yeah? You can say x equals x plus 1, right? This is allowed. You're allowed to add to a pointer. That's okay. You're allowed to say the dereference of x equals x plus 1, right? Yes, this writes to somewhere in memory. So as it stands right now, I consider this, like when I parse the left-hand side, I look for an identifier or something that can be a variable, right? We say variable equals something. But the complicated thing about this is we could have, that was a really bad star, I'm sorry, star, you could say x plus 1 equals 5, right? And this needs to be valid as well because we might want to assign to, you know, the nth index of an array. And in fact, I might not even do array syntax. I might just do this for now because we can do arrays with this, right? This is all you need to build arrays. So, but this is also interesting because there's something you aren't allowed to do, and that is to say x plus 1 equals 5. This is illegal, right? This isn't valid. And it's not valid because, well, what the hell are you assigning to? Like, what does this mean? What's on the left-hand side here? This is an expression, and you can't assign to an expression. But you can dereference an expression. So what I think the rule is currently I have assign. It takes a name and an expression. That was a really bad letter E. Please excuse me. Please forgive me. And you kind of end up with name equals expr, right? This is kind of the rule for what this looks like. So I'm gonna add a new rule. I can't shoehorn this into what is currently an assign, but let's say deref assign. Yeah, and this is gonna take, it's gonna take an expression and an expression. And the rule is gonna be star left-hand side equals right-hand side. Yeah, does that make sense? And this, I guess, can optionally be wrapped in brackets, but maybe not. Does that make sense? Whoa, I lost my thing. Hold on. Whoa. There we go. So instead of just being the name of something, now we have an expression. But without the star, we don't want an expression because this doesn't make sense. So anything after a star within brackets is allowed to be an expression. Okay, that's my rule. That's how this is going to work. And maybe as a starting point, I make the parentheses mandatory, because then it's much more homogeneous. So we can build this. We can build this. It's not going to be that hard. It's going to be a new expression. It's going to be a new statement type in my AST, and it's going to be a new parser. But we can do this. So let's go. Let's go. AST. Let's go to our statement, and let's do assign. Let's call it assign deref. We could also call it assign address. That might make more sense. But assign address is hard, right? Because assign address makes it sound like we're assigning an address to something, whereas what we're actually doing is dereferencing an address into to assign to the thing that address points to in memory. So let's go with deref. And we're going to take an expression. Let's make this a structy type so that we can have two things called LHS and RHS. I don't know why these expressions are boxed. Because statements are self-referential but only through a vector, so these actually don't need to be boxed at all. And actually, let's make sure this compiles by putting in the appropriate curly brace at the end here. Okay, so I can build this and it's going to yell at me for some stuff, especially because it's not present here. So let's deref. Let's do it. Let's do this. And we're going to have left-hand side and right-hand side. And all we say is star LHS equals RHS. That's the rule. That is the rule. So let's keep building and keep finding these errors. So code gen we probably don't want to touch necessarily right away. Okay, that's actually the only other place. This is the only other place we have to think about this. So, beautiful. Let's do it. Let's just write the code. Let's write the code that actually handles this. Bobbius2, hello, welcome. Come in, come in. How are you going? How are you going today? I hope the weather is nicer over for you than it is for me. Because holy crap, I am absolutely freezing. Okay, so assign deref, LHS, RHS. So what does it mean to actually do this, right? What does it mean to compile this? Well, we have an expression. That expression might just be a variable. It might be this kind of addition. It might, anything that yields a number is valid here, right? So we do the work, we end up with a number in the register, and then we evaluate the right-hand side, and whatever value we get as a result on the right-hand side, we assign to the memory address of the left-hand side. So we're going to need to use two registers here to juggle this. Does that all sound fine? That all sounds good. That all sounds good. Let's do it. Let's do it. So what do we need to do? The first thing we're going to do is... Now, we need to be careful here, because which side of this do we evaluate first? And this is important because there might be function calls involved. So let's say we're compiling this statement. Let's say we have our star, right? And then we say foo equals foo, right? Where foo is a function with some, global x, and it says x plus equals 1, return x. I promise that, I need to write a little better than that. Return x, right? This is horrible Moonman writing. This is incomprehensible. The idea is that we have a function that modifies some global state, right? So if we try and write the value of this function, like these two invocations are going to yield different things. Which address do we write to? And I think we just need to make a decision. I think it makes more sense to read this left to right, because that's kind of how you follow things through in your brain. So let's compile the left-hand side first. So we're going to compile the address. I'm going to remember to switch my scenes because that's important. And we're going to compile the address. Bobbia says it's been a hot summer, but not a humid summer, but not overly hot. That sounds tolerable. That sounds like a tolerable summer. I am not looking forward to summer, but I am also hating winter. It's the joy of living with bad insulation. Scope Excellent. So we compile the left-hand side, and then we need, so we write these, well actually we can do this on the right. We can compiled value, I guess. We have an adder, we have a value, left-hand side, right-hand side. These don't need to be dereferenced because they're no longer boxed. Compile expression. Okay, cool. So we have the left-hand side, we have the right-hand side. The order we write them to our program in is gonna go compiled, adder, do this one first. Sorry, out.extend. I learned about extend. Extend is cool. I like extend. Cricket, thank you. This is a high quality comment. Yeah. Thank you very much. Oh man, this is these are the joys of trying to write. I'm gonna buy a graphics tablet one day, but today is not that day. I needed to show that one on stream for all the people watching the VODs because that was good. Resolved instruction. Cool. So then we need to actually. This ends up with a value on the stack. So we just push both of these to the stack. Then we're going to pop the value into B and the address into C. Pop address into B, value into C, which means we just do 2 pops. C pop, so value into B, address into C, I think that's what I said, and then we store word. We store whatever went into B into the address at C, which is what this does. Cool, and that's the statement. You can get small ones, surprisingly cheap. Yeah, the thing I find, right, I end up in the AliExpress vortex where you try and buy the cheap thing, and then it ends up breaking within, 3 months, and then you have to buy a second, more expensive thing because you realize the cheap thing isn't going to quite do the job that you wanted it to, and you end up spending more money overall. So then I end up buying nothing, and that's probably worse. But oh, these are no longer mutable because I use extend. That's cool. Yeah, it's hard. It's a real struggle. XP pen is okay. I mean, listen, these things are all made in China, right? There's no getting around that. But XP pen, I'll keep that in mind. I had a Corel art tablet when I was like 8 or 9 years old. That, like my dad's friend like sold computer stuff and he got one super cheap. XP pen, okay. Having an Aussie storefront is a plus, because it's probably easier to force them to comply with Australian consumer law if stuff does break, which is always nice. Statement, where am I? Statement variable assign. I'm going to copy and paste. I'm going to do my favorite thing, copy and paste, except this is going to be variable deref assign. No defer. That's a different journey. Let me just XP. I'm gonna make a note of this. Okay. Once I'm employed again as well, I think that's gonna be an easier thing. I did pass an interview to do some after-school code teaching, so that's gonna be fun. I'm gonna try and do some more chill stuff for a little while. Some less. I don't know. I've got some full-time work in the pipe as well, but yeah, it'd be fun to do some random other small stuff for a bit, and leave time to keep streaming and working on my projects, because I think this is, if there's a time in my life when I'm going to build something good, it's going to be like now. Okay, so the first thing we want to do is skip white space. I guess what I'm trying to say is I guess I'm kind of at the top of my game in some way. Late 20s, know a lot about programming. This is the time to just try and build stuff. Defer is a nice keyword. I would love to do defer, and it's actually not impossible. It's not too crazy, but might be outside the scope of language 0, right? This is the bootstrap language for writing code for the virtual machine. It's probably more complicated than a bootstrap language needs to be, but I wanted to, write a language with a compiler and do this because I've never done it before. But once we have this language running on the machine, maybe we can write more interesting things in the language itself. I don't know, that feels like a big undertaking. But We'll see. We'll see. I definitely want to write a Lisp. That's high on my list. So we find this star token. We find star. Then we look for an opening. Actually, it's going to be a wrapped. So we'll say let S1 LHS equal skip. We're going to skip white space. We're going to look for a wrapped expression. So an expression that has a token, open parentheses, then an expression, then a token, right parentheses. Excellent. Then we get rid of this. This becomes 2. This becomes 3. 1, 2. My handwritten monads continue to thrill. Assign deref. And now all we have to do is this. No semicolon, because this is the return. This is now called RHS. And this is going to build. S3 is unused. And now this is going to build. Beautiful. That feels good. That feels good. Well, actually, hold on. Statement. Variable deref assign. Okay, so we need. I think this goes here. Because it starts with a star, it shouldn't be too important where we put it, but let's try here. Excellent. Okay, so variable test assignment. Let's put this in test assignment, even though it's a different thing. Actually, no, let's not. Let's make our own function. Assign deref. Okay, expected. Oh yeah, this was before. This was different. This was standard variable assign foo equals. Hold on. Whoa. Let's do this thing where I say x star x plus 1 equals 57. We're gonna run the parser on what our expected output is. How do I do this in other tests? Expected run parser. Oh yeah, and then we just say toString. Cool. Okay, so that blew up. That's okay, but that did blow up. Dinkelman, welcome. How you going? It's been good streaming at some slightly more random times during the day, getting some different faces in. This was really silly. Student variable assign. That failed because I was running the wrong parser against it, which, you know, helps. Variable assign. What broke here? Hold on. Statement variable assign 100. Statement variable assign. What did I call this function? What the hell? I called it deref assign. Okay. Actually, let's call it assign underscore deref because that makes way more sense. That's more consistent with everything else. Deref. Now it works. 7 a.m. You're just going to bed. Wow. Good luck. Thoughts and press. That's early or late. I'm not sure. Last stream was 8 a.m. for you. Fall asleep at 5, 6 a.m. Wow, guys. I don't know how I feel about being nocturnal. It's not great. Okay, that is just because my spacing was bad, which is fine. Nice. Okay, so we have dereferencing. Now let's write some actual code tests for this. Let's write some code tests. So we should be able to take the address of a global, write something to it, and then then retrieve that address, right? So if we have our global foo, let's get the address of foo, and then let's say b equals 77, and then return foo. right? Can we assign to a global variable via taking its address? And then we would expect this to be 77. And this is probably going to blow up in some way, right? The parser might yell at me. I might forget to rename my test, assign deref. Yeah, of course, it blows up, right? You've always been nocturnal, go to bed anywhere between midnight and 3. You can never get to sleep quickly. Wow. Yeah, I have, my sleep schedule has been drifting a bit later lately. But that's just because I'm on computers too late. If I want to sleep, I just have to like get off computers by 9 p.m. or something, and I rarely do that. It's one of those things. I know what to do if I want to do better. It's just having the self-discipline to do it. Okay, parser error main blah 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 blah. So what is this? Context. So star b tag none expected token and a bracket. Okay, so if I get rid of this, does this pass? Yes. So it's this line. It's unsurprisingly this line. You have a weird social life or lack thereof. Sometimes you go to bed at bizarre times. That makes sense. I was actually out last night, so I had every reason to come home and just go straight to bed, and I still didn't do it. Right? But my new thing, right? If I'm feeling restless at night, I listen to podcasts, and that's a bit more chill. Schleiden's Dev followed me. Thank you very much. Welcome to the Rust family. Man, yeah, I don't know. I'm not. I don't know if I have ADHD, but I definitely check a lot of ADHD boxes. Yeah. People who struggle with stuff like that, it's very relatable. It's very relatable to me. Okay, so this doesn't pass. This doesn't pass. What goes wrong? It's the thing it says, it's looking for a close parentheses here, which means, so this is the thing that's trying to close the entire block, and that's not right. Expected global, that's also not right. So this thing is trying to parse the entire function as a global, and that doesn't work. This thing is trying to parse the entire function as an inline assembly block, and that doesn't work. And this thing is just saying the whole thing. So, we're finding an unexpected character, right? And this is almost certainly down to the order that we're trying to parse these things in. Almost certainly down to the order we're trying to parse in. So let's go assign D. We know we can parse this, okay? So we try to parse, we look for this star. I don't understand why we wouldn't find this star. Statement. Statement terminated, statement continue, statement, well, yeah, this all looks good, So, not a Rust guy, you're just a dev, that's absolutely fine. I'm not a Rust guy either, despite having written a couple of thousand lines of Rust code, I'm not a Rust guy. I am learning by failing forward. If I keep bashing my head against this wall, I'm going to turn into a Rust guy. But I don't think I'm there yet. I did actually have a recruiter say he had some Rust jobs, so he knew of some Rust jobs in Australia. So hopefully, maybe I will be a Rust boy. I've got opportunities. I've got potential. I might meet with some Rust shops. Fighting to go to bed. Yeah. Look, I appreciate you stopping by. I appreciate you hanging out. But if you've got to sleep, you've got to sleep. Don't fight your body. Don't fight your body. Let me just try plonking this down the end and see what happens. So it's weird, right? Because this is saying that it expects what this is looking for. I need to improve my errors. I have to do something about these errors. They're unparsable. Okay. They're ridiculous. These are ridiculous. Also, this is actually really dangerous, right? This is If your recruiter needs a full stack JavaScript man, yeah. Um, no, I'm in the back end world, so I don't know anything about what's going for JavaScript. I'm also in Australia. I don't know where you are. Uh, Schleidens with a name like Schleidens. I assume not Australia. Sounds very like German, Northern European to me. Um, Unless I'm mispronouncing it and Germanicizing a perfectly innocent name. Okay, this is actually going to cause me a problem at some point, but that's okay. We'll leave that for now. I say your name well. Thank you, thank you. I've sung a lot of I've sung in a lot of choirs. So despite being a bogan reclusive Australian, I know a lot about European languages, right? I've sung a bunch in German, I've sung a bunch in Italian, I've sung a bunch in French. It's been very informative for me. I've learned a lot of stuff. And yeah, I've had a lot of conductors be very passionate about how to pronounce German words. IE and EI, all that good stuff. Okay. How do I make these errors not look like this? This is really what is killing me right now. Bobbius says I need a parser for my parser errors. This is not an invalid point, but the problem isn't even that the errors are hard to read. The problem is that the errors actually don't give me much information. But like part of the problem is, right? So when we have this, we're going to try all of these expressions. Let's look at the statement case, right? Because this is what's actually happening. So we're stepping through, let's split this. Pointer. Okay, so what happens? We look at this first statement, and we're like, okay, scan through the list. Not an if statement, not a while statement, doesn't have a star. Starts with let. No. Starts with a let. This is a declaration, right? So we know this is a declaration. Then we move on to the next statement in the function, and we go through the list, and we know it's not an if statement, and we know it's not a while statement, and we know it's not. Well, I mean, it should be an assignment, but for some reason this isn't triggering. So we keep going. We try this, 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 and then we reach the end and we say, okay, I give up. But the error that gets passed out is the last thing that we tried. But that doesn't even matter, because then when we come up to the function definition, repeat one, we just it just gets munched. It just gets munched, right? It's just gonna get munched. And the errors we can see, because we have any collector. Wait, can I just change this? Oh no, sorry, I have any collector. So it is actually gonna, so why doesn't it collect these errors? It doesn't, huh. Maybe something else is happening here. Because we should actually get a list of errors, right? So if I look at this, we actually tag none. Huh. Because this is where it tries to... So this parse error is the one where it's... Why is it saying expected token close bracket, right? What it should be saying is that it tried and failed to parse a statement. That error should get passed through. So repeat one, function definition. Repeat one or more of these. This is actually the problem. It's repeat one, right? What's my backend stack? You've got Node, Express, Postgres. I just write Golang. That's basically it for the last couple of years. Golang, Postgres stuff mostly, building on AWS and GCP. That's my background. One of the things I love about Golang, and gRPC protobuf as well. That's the other thing that I've got some decent experience with. One of the cool things about Golang is you don't need a framework within Golang. You can just be a Golang person, and there's enough out the box that it's okay. So repeat one is the source of all of my problems here, right? Repeat one is the problem. Because we throw away the error. We throw away, if we hit an error, but we've already found one or more things, we throw away the error. And it's hard to know what to do about this, right? It's hard to know what to do about this without more logic anyway. So here's what I'm going to do. I'm going to do this. And this is going to tell us what is failing to parse, right? This actually has all of the statement errors in it. And here are our statement parsing errors. Okay, so parse error, expected if. So this is not the one. This one's going to say expected while, and that's okay. This is going to be the one. B, expected token, open parenthesis. Oh yeah. I'm just wow, I'm just really silly today. You've got to wrap this in parentheses. Now this is going to work. Now this is going to work and give us the right... It's not going to give us the right answer. Now it's going to do something. It's amazing. You tried Golang briefly and didn't like it. The tooling was great. The standard library was missing too many quality of life things. That's interesting, because the standard library has a lot of stuff in it, right? Go is fairly batteries included. You don't need to pull in loads of dependencies to do stuff. Go, you haven't tried it out. Go definitely, it's verbose. It makes you do a lot of tapping to get through some things. What do you think was missing from the standard library, right? Are you talking like... Because it's very good. If you're building web services, the standard library kind of has everything you need, I've found. You probably don't want to do it just with the standard library. You probably do want to pull in some dependencies to make your life easier, but you can write some very lean Golang binaries that, you know, build and deploy everywhere and don't have a lot of external dependencies. Okay, we're trying to assign to this global. And we've got to look at what the code is actually doing here, because that's the only way we're going to work out why nothing has actually been written. Doing advent of code. Oh yeah, no. Go is not an advent of code language. That's freaking miserable. Go is verbose in a different way. Rust is verbose in a way where you get all these guarantees about like type safety and the borrow checker, and you know, if you put the work in to that verbosity, you get a lot back out. C# I can't really speak to. Java verbosity is just a nightmare. Go verbosity is like you write a lot of manual error checking in a really tedious way. Yeah, switching to Rust instead. I'm enjoying Rust a lot. I think they check very different boxes for me. If I had to work at a big org again, or even at a medium-sized org again, I would definitely want to do Golang, because I think it's a great language for collaborating with a lot of devs. I think you end up with very sensible, predictable decisions that are easy to communicate with people. I'm not sure how Rust would go if I was collaborating with like 10 other devs and we were all trying to make changes. I think it would be easy to step on each other's toes a lot without a really good lead architect who, you know, kind of had a finger in every pie. Okay, so, but yeah, so I think I'm going to keep writing Go and I'm going to keep writing Rust. That's my goal. That's my dream. So, sorry, I'm trying to focus back on my code, and chat has been is too entertaining. You like Lua? Lua's fun. I like Lua. I don't dislike Lua. I have problems with Lua, but it's a great scripting language. I think I mentioned before, right? But when I was in Adelaide and I was sick, I started messing around with writing a single binary web server that you could write HTML and you could enrich it with Lua. You could have like special tags like mustache templates, except with Lua. You could just run arbitrary Lua. And I thought that would be a really fun environment to web dev in. That's my goal. I'd love to bring that up and finish that on stream one day. Professional work in TypeScript. Yeah, exactly, right? Like, TypeScript, I wouldn't want to collaborate with other people, and not because they're stupid, necessarily. Some people, you know, don't put the work in to be good programmers. A refusal to learn, I think, is a big thing. But TypeScript, like, there's so many ways to shoot yourself in the foot. It's like C, but like, in C, if you do the wrong thing, your program crashes. In JavaScript and TypeScript, if you do the wrong thing, the program's okay, but the code quality just gets like really, really messy. Lua would be a better web language than JavaScript is. I wish there was a parallel world where we got Scheme instead of JavaScript, but after that, where we got Lua instead of JavaScript. That would have been great. Okay, so what has happened here? Where we B0 stored, we write, let's see the word C0. So this no, that's not what I thought it was. So we're taking the address of the global, then we're loading 77 We're going to push that to the stack. We're going to pop it out into the B register. We're going to pop the address into the C register. We're going to write it. So that's okay. That's okay. Actually, you know what would be even better than this? What would be even better than this would be... Can I copy this? Would be to run this in the actual... oh, that didn't work, did it? Where did I get to? C77, load, C push pop, MB0, stack C push. Let's try this. Oh wait, these are the instructions I'm running. That doesn't work. Hold on. I can't copy and paste like that. These aren't ordered. I need to copy this into my file and then assemble it. We've got to step through this one at a time. I can't visualize this data flow well enough. And it's only going to get harder to visualize stuff from here. So let's cargo test.code. We're going to pipe this into our disassembler, and then we're going to copy this. Cool. Oh yeah, I have a virtual screen running now. This is my goal. Like, whoa, where did that go? Once I have deref working, I'm gonna try and use it to write stuff to a virtual machine. Okay, a virtual screen rather. Okay, so Lua's a sensible take on JavaScript. Yeah, I think Lua does a lot of JavaScript-y things, but I think it's much more sensible. WASM is cool. I don't know if it's superior, but it's very cool. TypeScript. I definitely think TypeScript is much better than JavaScript. Try some other languages. Yeah, definitely experiment. You learn a lot from experimenting, as Bobius is saying. I've learned a lot from playing around. Like, build a Lisp. Do structure and interpretation of computer programs. It'll change your life. Okay, so 0. What is 0? 0 is the address of our global. Okay, 0 is the address of our global. So we load that. We pop that into register C. Why are we're getting the base pointer? Because we're storing this in a local variable. We're storing this in the first local variable. Okay, so this is the address of our local. This is the address of our global. We store 0 here. Okay, now we put the base pointer in C, we add 0 to it, and we load into C the address of the base pointer. Perfect. The address of the global. So this is good. So this is what we expect. So we push this, then we load, we basically swap. We end up with, yes, this. Okay. So we have the address in C and the value in B. Wait, that's not right. Value in B, address in C. Okay, well that makes a lot of sense then, because I did it backwards. That's what I'm trying to say. Assign deref, sorry. So we want to store word. We put the address in C, so we're gonna store the value of register B into the address at C. And now we're gonna make T and it's gonna work. Beautiful. Okay, so now we get to do the fun part, where we write some example programs with this. Add deref. Well, actually, no, hold on. There's something else we're missing. SEIP is amazing. Biggest issue with TypeScript is it's not a first-class language. Yeah, this is definitely. Like having the weird compiler step. Yeah. Wrong opcode order problem. Yeah, off by one error. It's hard as well when you're assembly you're writing this format and it looks really gross. Like, it would be cool to maybe have a macro that made this better. That keeps ringing around in my head, and I'm not going to do it because that'll turn into a project in and of itself, like writing a macro DSL to do this, but it's in my brain. Okay, okay. That's where all this started, really. Yeah, do this. This is a good link. This is a really good link. It will literally change your life. Anyone watching on YouTube that wants to learn about languages, I'll try and remember to put this in the video description. Actually, it's good. It's a good time. It's a very good time. Okay, so this. Okay, but there's something missing, right? There's something missing from my pointers. Something very important that I neglected to really draw much attention to. And I didn't draw it in my table, okay? So what case have I missed? Because can anyone see? Can anyone visualize what pointer operation I don't have here? Nobody. 200 volt, 200V. Welcome. We are deep. We are inside the pointer. We are programming the pointer. Okay. The case that I've missed, and this is a very, very important case, is where you would say y equals x plus 1, right? Where the dereference is on the right-hand side. And this is valid. We're allowed to do this. This is a really important operation. And this actually, it behaves really similarly, but from our parser's point of view, it's kind of like, this is just an expression. Now, there's an interesting thing that's going to happen here, okay? If we're allowed to have a star followed by an expression, and we're also gonna hit the problem where, well, what am I trying to say here? Parentheses don't exist yet. My language does not understand parentheses. So let's write a parser that understands star expression and that this whole thing is an expression. That's gonna be simple. Then, once we implement parentheses around expressions, that's going to simplify our left-hand side parser, because then we just say star expression. We don't need star parentheses expression. It's going to be even simpler. Are you 200 volt or are you 200V? What's the which is it? Is this are you Bible thumb by said volt, or that I wasn't sure if it's a volt? I'm not sure how to interpret. Okay, so let's add a new expression. Enum expression. And again, maybe a unary operator would be good, but for now, let's go. It's going to be a thing that references an expression. This is going to be just the dereference, I guess, dereference operator. Do I just call it deref? I'll just call it deref. Everything else is deref for now. And we have to use a box for our expression because this has to go via the heap, because you can't have an enum that contains itself. Otherwise, that enum would have infinite size. And computers, as much as I would like if they supported that, computers do in fact not support infinite size. Okay. So let's copy and paste from address of, because deref is going to be mighty similar. It's just going to be a star instead. Cool. Now let's build this and see where we break. Okay, when we resolve, oh yeah, this is interesting. Well, this is interesting. The type of an AST expression deref, dereferencing an expression. Well, we need to match this expression. Okay, if this is, actually we can probably if let AST expression. No, wait, hold on. We need the type of the inner expression. I'm getting ahead of myself. Let inner type equals type of expr. Then we want to say if let AST type. Let me remind myself what my pointer. I think it's just called pointer. If inner type is a pointer, then we just return t. Otherwise, we've got a number. It is just v. Okay, first time seeing Rust programming. Excellent. Well, you've come in at the perfect time just about, and thank you very much, Nobody 200V, for the follow as well. This is a great example of cool ways you can use Rust using destructing assignment to make this kind of structure easier to deal with, right? So if we have a pointer, we can just return the thing inside the pointer. Returns are implicit because this is just an expression. If it's just an expression, the last expression in a block is the return value of that block. AST type pointer t is inner type. Otherwise, what do we do if we're dereferencing something that isn't a pointer? What do we do? What do we do? We have to make a decision, and a thing that is not a pointer, right? We're dereferencing a thing that isn't a pointer. So maybe this is an instance where the type is just void, right? Or maybe this is an instance where we just have a number. And I think for now, type of. That's not an AST type anymore, that's just a type. Let's just say type int, right? Let's just say, okay, I give up. I don't know what you're doing, but I'm not going to stop you doing it because C, because we have C-like semantics. Type of block scope. Yeah, I missed the thing. CTX scope. We need to pass in our arguments. Okay. Expected type found box type. I think we can. Maybe we have to clone this as well. Okay. Nice. Now when we compile a deref, this is actually going to be pretty easy, I think. I think it's going to be pretty easy. Let's try it. It's going to be like an address of, but in reverse. Okay? So let's say AST expression deref e. It's actually going to be way simpler than an address of, right? Because we're going to compile an expression. Compile expression. We're going to call this recursively. So we're going to pass in the context and the scope, CTX scope, and we're going to pass in this expression. We are going to... We need somewhere to put this, so we'll say out.extend. Actually, we can just crunch this down completely. Compile the expression. So that expression is now, the value of that expression is now on top of the stack. So what we need to do is pop it from the stack, load the word at that address, or the byte at that address? Is this the case when a user is dereferencing the pointer with the wrong type? Yeah, well, when you're dereferencing something that isn't a pointer, right? Like in C, I don't think C stops you. I don't think C would stop you if you wanted to say like, actually, what would happen here, right? If I say int x equals 5,000, right? Can I do that? I'm pretty sure I can do that. I don't think C will stop you. Maybe you have to say, maybe you have to do this, right? Maybe you have to cast x via an int pointer for that to work. Maybe. I'm not sure. I could try and compile this. What would happen? Okay, let me write this to temp c.c. Cast a pointer. Okay, so that works, obviously, because it's C. What about this? It would obviously segfold if we ran it, but what happens here? Okay, C does not allow this. I think by extension then, we will not allow this. We will say, so this function currently doesn't return an error. No, this is different. This is very different to what I'm doing. This is hold on. So let me speak to this really quickly, right? So x equals 5,000. This is saying that memory address 5,000 equals 7, right? Now this is saying that x equals 7, but this is saying that memory address 5,000 equals 7. There's an important difference between the two things. It's good to know that C doesn't allow this, but this means that I'm now going to actually have... actually, no, well... Shouldn't it be in hex format? That doesn't matter. They're all just numbers. They're all just numbers. It doesn't matter if it's a base 10 or a base 16 number. People usually do memory stuff. People usually do memory stuff in base 16, but there's no reason. Void p equals, yeah. Oh yeah. See my PlayStation 2 work where you can just do this and then write to that address and it's valid. Okay, so actually, instead of, this is bad, but I'm just gonna return void for now. And I'm gonna make a to-do here. This should return. I don't know if we want to decide there's an error when we resolve the type of this thing, or if that lives somewhere else. But maybe this is actually the right place for the error to come up. I don't know. We'll find out. We'll find out. So, deref. I guess it isn't the right place because we're trying to, like, we don't actually do the check when we compile this, right? We don't check the type of E. Maybe we should. Maybe we should. Let's let inner type equals type of scope E. Right, so if the inner thing isn't a pointer, then I guess this is an error. So if if type pointer t what's the best way to check for a variant like this? I guess we could say if inner type dot is pointer. Right, that might be a good way to do it, and then we can say return where are we? Compiler error deref valid type. We're gonna add a new error variant for this. But this is a good thing to check. This is a very good, sensible thing to check. You just took C++ last term, you hate it. Yeah, I mean, if you're learning C++ in an academic setting, you're probably learning C style C++. You're probably not getting into a lot of the things that people hate about C++, but C++ is complicated. It'll force you to learn stuff. If let, this might be better. Yeah, actually, that's, but I want the not. I want negative. I want this early return when it's not a pointer, and I don't think you can do if not let, right? That's the problem. This kind of destructing pattern matching I don't know how to apply it when I want the negative case. I could just put all of the positive case inside here and return an error, but I don't know, I don't like that as much. I struggle a little bit with that. I'll see how long this code is. So we compile the expression, that leaves the expression on top of the stack. Then we need to pop the instruction, which we're gonna grab from down here. Instruction, we're gonna pop from the stack, pop into C, then we're gonna do my favorite instruction that I've ever written, which is load word, and we're going to load from the C register into the C register. We're going to load the address in the C register, and the value is going to go into the C register. Do we load word? That's the other question. Because what if it's a pointer to a car? So actually we need to check. Also, we need to actually do something with these instructions. That's a bit silly. Out.push. I guess we can say, hold on, that's not lined up, is it? Is it? What's going on here? I'm out by one space. I could see something wasn't right. I had to really get my straight edge out to see that. Okay. So we're gonna load C. We need to check if inner type dot byte size bytes, byte size, what did I call this? Size bytes. I think I should call this byte size. Size bytes, that's what I typed, right? Size bytes. That's what I typed. If it's 1 byte, then we want to load. Let's copy and paste this real quick. Load byte, else load word. What if it's a struct? What if it's a struct? Good lord. Heaven forbid we ever dereference a struct on the right-hand side of an expression. Again, I don't know if that's valid. Oh, wow. I don't know if I want to really draw attention to this, but the Barber Is You Anointed dev is streaming. I don't know why anyone's watching me when when that's going on. No, that's really cool. I love seeing more and more known people streaming. Like, I mean, watching Mr. Weeble the other day, that was insane. I didn't realize that was the Mr. Weeble, like the Badger song guy. He gave me a shout out. It was crazy. It was freaking crazy. Yeah, he was live streaming. I doubled his viewers when I raided him. Like it was nuts. How is this guy not more like, how is this guy streaming and there are more people, or like the same number of people watching me as him? This guy is like one of the most internet famous people I could think of, but also I don't think anyone actually knows his name. Okay, so I don't know what to do if we're trying to load something that has more than 2 bytes. I don't know if that ever like, well, I guess okay, that's more complicated. It's more complicated. We're going to have to really do a big think. And then we just have to push the C register onto the stack. I might be painting myself into a little bit of a corner by never handling this case. But also, I guess it just means we can maybe never value assign a struct, and maybe that's okay. Maybe that's fine. Maybe value assigning structs is for chomps. And I am out by 1 character again. Okay, so if I build this, what happens? Couple of things. This doesn't need to be wrapped in parentheses, that's good. I need to deref this. Or can I just borrow a box? Is that okay? What happens here? That sounds good, Is pointer. Okay, so in type, I want a pub function called is pointer gives back a bool. We want to say if let self pointer. So if this is a pointer, so this is using the destructor that Bobbius demonstrated in chat before. True. And there's probably a better way to match enums, but this is okay. I mean, I could use a match statement as well, right? But because this is one or the other, and if let seems to make more sense for now. Okay, so what else do we have? Oh yeah, I forgot to add my error variant. Deref invalid type, and this is gonna take a type. Expected expression, found box expression. We're gonna borrow the box. Or not, we're gonna as ref the box, I guess. That's fine. Expression. Oh, wait, expected expression. Hold on. Why does this take an expression and not a reference to an expression? That's a bit silly. But that's okay. Okay, cool, that works. So now let's define the expression version of deref. And this is actually going to be really simple. Pub function expression deref. And I think this is going to actually be one of the first expressions that we should try to parse, because it has a really distinct opening character. So let's first skip white space. Let's try and grab the star token. And then we're gonna just try and parse an expression. Now, there are 2 expression functions. There's expression left-hand side and expression. And I think we want expression. Expression this needs a question mark. Okay. AST expression deref box new. Beautiful. Now this can go anywhere, I think. Left hand side. I think this can go on the this is any expression. Any expression. Let's say expression deref, right? Because the only time, well, we might see a star in a binary operator, but most of the time the only time we see a star is going to be here, so that's fine. When we build this, it works. It actually works. Test. Test expression deref. So we're gonna say foo equals we can do this, right? We can say foo equals whatever is at memory address 500. That also, hold on, that doesn't work. Okay, is this going to pass the test? No. Expected token star. We put a star. There was a star there. There was, in fact, a star. So what's going on here? What's going on here? Skip by this token star. Token star. Curious. Very curious. Expression deref. What could be happening here? What could be happening here? There can't be too many things going on, right? You're only checking for the deref expression that's on the right of the assignment. Yeah, but that's fine. Wait. That's what I'm doing, right? That's the whole point. Because we have the left-hand side on the right of the assignment. That's why I've got two dereference. Like, they have to be different things. They just behave a bit differently. Because the left-hand side of an assignment statement is not an expression, it's its own thing. I'm not getting into L values and R values. I'm just writing two parsers. Cynochron, how's the lang going? It's coming together. We're near the point of being able to do cool things. Thank you for stopping by. Thank you for checking in. Illinois, thank you also for the follow. Welcome to the club. Welcome to the crew. We are building a programming language, and it's gonna come together in a really good way. We're very close. We're very close to some good stuff. The deref expression itself, let a equals isn't a sign. The deref expression is it's just star 500. Oh yes, you're spot on. You're spot on. Thank you. The problem here is that I'm actually just this parser is just the expression. So now when I test, it's gonna work. Yeah, excellent. Okay, so let's actually try this foo bar. Right, this is dereferencing foo bar. Cool. Thank you so much, Bobius. No, that was hard to parse, but that made sense. Hard, no pun intended. That was hard to parse for my brain because my brain's thinking about the difference between the left-hand side and the right-hand side. So that was a fun, reality diverging from where my brain is. Okay, so deref values are Henri. Is this my own language? Yes, this is my own language. This is my own C-inspired language. So let's see. Let's do a slightly different thing. Let's do one without a global. Let's write a test. X equals, this type will soon be optional because we're going to be able to infer it, but that's okay. Let's say X is 77. Let int b equal the address of X. So we take a pointer, we write what am I trying to do? The deref of X. Let's maybe say return star b, right? Return deref b. Return 77. We expect this to be 77, except let's make it a different number. Let's make it 97. Oops. Is colon equals assignment? Yep. I've gone for colon equals because just plain equals, like this way you end up with equals equals for equality and colon equals for assignment, and single equals does not exist anywhere. That's my programming utopia. Is for which processor? This is my own 16-bit virtual machine. Runs on the web browser. So this is, I'm doing everything. Writing my own tools. What has happened here? What has happened here? Deref values fails. Deref values panicked. Instructions. Unwrap error value context. Whoa, that's different. Where did this fail? Hold on. What line is this on? What failure is this? Didn't expect this. I haven't seen this specific panic for a while. Unwrap test common 44. That's the wrong common. 44. Compile. But that looked very different to my other compile errors. That's weird. What's the reason having both let and colon equals? Because let for declaration, right? So there's no single equals. The reason for having let and the type is that there's currently no type inference. Once there's type inference, it's going to look better. And I'm really close to type inference. I'm like, it's just around the corner. I'm just the tiniest little bit away. Okay, so what has happened here? What compile has blown up? I'm confused. Unwrap on an error value. Oh, deref invalid type in. Sorry, that makes perfect sense. That makes perfect sense. Oh, wait. I messed up. I really badly messed up. I need to just like clear my head for a second. That was, what did I do here? I did something really weird. Resolve? Okay, so type of a dereference instruction is the thing that the pointer points to. The type of a deref expression is the thing, the inner type. But what am I doing? Hold on. The inner type is a pointer. Yeah, so why is this just an int? Why are we trying to dereference an int? Because this is clearly an int reference. Heistman24, thank you very much for the follow. Welcome to whatever's going on here. We're getting increasingly manic. Jai syntax or declaration, variable name, optional type equals expression. Yeah, I thought about this, right? It was really just a matter of, you know, I guess kind of preference. But that's a cool way of handling the Walrus style assignment. I like that, where you would instead have, yeah, like x int whatever, but then this is also valid. That's kind of cool. I want this to look C-like, kind of, but also it's going to drift further away from C the more we go. Odin uses the same syntax, which collapses with type inference. That's also cool, yeah. Maybe I should do that. I don't know. Nothing is set in stone. I can change whatever I like. It's my language. Okay, so I really need to think about how I'm following this through. I need to think about how I'm following this through. Invalid type. Dereference an invalid type. Int. So what happens in our code gen? Right here. So we come in, we get the type of the nested type of the whole inner expression. Well, the type of the inner expression is the type of the variable, and the variable b should be a pointer. Already with let, it doesn't look much like C. Apart from the walrus operator and the word let, it's very C-like. It's very, very C-like. But you have a good point. I will take that as a fair criticism to everything I just said. So we get the type of the inner expression. The type of the inner expression here for this test, not this test, sorry. This test should be, so the type of this thing, it should be int pointer. It should be int pointer. But for some reason, we're just getting int. So how does that happen? Resolve. Type of a variable. Local t. I'm going to do a really stupid thing here. I'm going to println the context. Right? Because I just need to know what's going on. And it's the easiest way to do it. Whoa, I accidentally pasted. Replace let with okay. So isn't there an isolang that does something like that? Getting dangerously close to intercal. Yeah. Globals. Oh, hold on. I don't want to print the context. I want to print the scope. I want to print the scope, and I probably have to do that via a debug. Scope. This is going to tell us what B is. Parent func ref cell to this thing. Locals, labels, none, locals. B1. Why are these block scope? Label, string usize. Is this, did I write placeholder code? I wrote placeholder code and then didn't deal with it. Yeah, lol code. That's the one I was thinking of. Okay. I wrote some placeholder code and then forgot about it, and now it's really upsetting. We need to also store, well, we need to also get the type. Hold on. Wait, we have the type. So a block variable stores usize, local index. So we actually need, we just need to store the type as well. That's actually not too hard. Locals.clone, locals push index. We need to send a type in with this as well. We can just do a reference to a type, then we say type.clone. Locals, KIT. Type will return the actual thing this time. KIT, if K was there, return T clone. Okay, here we go. Now we're getting somewhere. Block variable local. I have some IT local IT. This is going to work first time, no problem here. No problems at all. Define local. Okay, so this is just where we pass in a type that I need to build instead. I've definitely forgotten a little bit of cloning here that might be needed. Intercal has the best control flow operation, the come from operation. How does the come from operation work? How does that work? That is good. Okay, we need to pass in, this is good. This type is now used, so that's something. That's something. Enum takes one argument, but two are supplied because I forgot some parentheses. Okay, we're getting better. Expected resolve type found AST type. Maybe we need to say dot into. Resolve type found AST type dot into. I'll open that wiki page in just a second. That's fun. Oh, hold on. We have already done this conversion. My mistake. TT. One field found two. That's because this requires parentheses. There we go. Now if we test, we're going to find that Okay, it still yells at us, but just for a different reason. So that's something. That's something. Hold on, hold on. Oh, is this thing? I think I've seen this before. Oh gosh. Oh gosh, I have to be somewhere in 1 hour alarm just went off. Computer frame come from its obscure control structure, originally as a joke. It has a go-to. Given as a parameter? Wait, the point of code where the state transfer happens before or after the instruction. What will come from? Oh gosh. Ah, when coding the label, control gets passed. Whoa. That's as a response to go-to considered harmful. That's insane. Over RM40 not the come from statement causes the branch back to that line when execution. That's actually insanity. Wow, I hate it. I really hate that. Thank you for sharing it. That might be the most insane thing I've ever seen. Okay, unwrap. That makes sense. Lang test pointer. Translation out of bounds. Out of bounds. Translation out of bounds because. Okay. I'm gonna change this into a test that might pass. I'm gonna try and change this into a test that might pass. Let's say foo equals 97. We get the address of foo, and then we'll try and return the deref of that, and that works. So let's make a test that fails. Okay, let's make a test that fails. Deref values local. Let's call this deref values global. Interestingly, this means that getting the address of a local is a little bit broken. Let's make it 121 because that's a fun number. 121. Okay, so why is this number so wrong? 3FF4. This number literally makes no sense. But it's probably actually not that bad to work out why. Probably not that bad to work out why. But given that I have to be at a pub playing Irish music in 1 hour, that means I have to leave in about 30 to 40 minutes. I'm unfortunately going to have to leave it there for today. So, no playing around with a virtual screen for today, sadly, but hopefully next stream, hopefully tomorrow, that's going to be what happens. So let's find a cool streamer to pass some viewers onto. Is the Noida dev still streaming? They probably have a bunch of viewers. I don't want to raid someone much bigger than me. Roguelike Dungeon Crawler in Minecraft. That sounds kind of cool. Fun stream. Thank you, Cricket. I hope I didn't chat too much. I hope that didn't detract from actually getting stuff done, but I had a lot of fun. I like hanging out and chatting. I had a very social day yesterday. Feeling very social today. Good luck becoming a software engineer. Up at 45. Yeah, okay. That's not. I feel like that's within the acceptable raid window. Okay, that feels like the tolerable raid window. Let me just pull up all of software and game dev. Twitch's raid UI is a little bit limiting, I find. I could also just raid Farscape official. I've been watching a bit of Farscape. That's been good. Where is it? Dead Sun Prime, QTT, making a virtual club. I don't know, roguelike Dungeon Crawler in Minecraft sounds fun as well. Did NZG trick me? Yeah, well, I don't know if they tricked me. I think they were watching Farscape and I watched Farscape and I enjoyed it. I like sci-fi. Farscape's pretty trashy sci-fi, but I like sci-fi. I'm gonna raid roguelike dungeon crawler in Minecraft. That sounds fun. What's that channel called? Mulberry 2. All right, let's throw some viewers over this way. Does not accept incoming raids. Let's try again. Let's try again. What's their channel? Hempuli. Hempuli? Oh yeah, okay. They're not in software and game dev. 46. Sure, let's do it. Let's do it. That sounds fun. That sounds fun. All right, here we go. Here we go. Let's throw some people over their way. Let's see what they're working on. Thank you so much, everyone, for stopping in. It's been a very fun stream, very chatty stream. And yeah, have a great day. Have a great evening. Have a great rest of your weekend, depending on time zones. And yeah, let's just chuck a couple of people over here, and I'll see you next time. Bye.